So welcome back on the online math class of class 12 and good afternoon all of you. Previous day we have completed 7.10, also 7.11, that means 7.11, there is a video has been uploaded on YouTube, offline video. Okay, today we will start area, application of integral, that is area. You know that the main objective of definite integral is to find out the area. Okay, that I am telling you once again. Suppose it's a function y equals to fx. This is a line x equals to a. This is a line x equals to b. Okay. Now, in this chapter, we have to find the area between the limits. That means two lines. Here, the first case I am talking about. The first case, the area A of the region bounded by the curve y equals to fx, x-axis and the lines x equals to a and x equals to b is given by a equals to integration a to b y dx equals to integration a to b f of x dx. Okay, the area A of the region bounded by the curve y equals to fx. This is the curve, x-axis, you know that. This is the x-axis, and by the lines x equals to a and x equals to b is given by equals to a to b y dx. That means here the limits with respect to x, and you have to transform the function in terms of x. Okay, you have to convert it into terms of x. So integration a to b fx dx. This is the first case. Yes. What are you trying to say, Bharshati? Type it. Is it clear? Is it clear the first case? Can I move on to the second case? Will be there any pre-board? Still I don't know anything about it. If I got any information, then I will tell it to you. Okay? I will intimate to you. The second case. This is the curve x equals to zy. This is a line x equals to d. Y equals to d and y equals to c. Okay, now here the area A of the region bounded by the curve x equals to zy, y axis and the lines y equals to c and y equals to d is given by a equals to integration c to d x dy equals to integration c to d g of y dy. Okay, this is the second case. Is it clear? The second case, this region. Can I move on to the exercise 8.1? And one more thing to say, area between two curves has been deducted by CBSE due to COVID-19. Okay, so only the area under simple curves. We'll do area under simple curves. Area between two curves has been deducted from the syllabus. So move on to 8.1, that is page number 365. Okay, move on to 8.1. Go through the problem. And one more thing, at the end of the class, we will take the attendance. That means you have to type your name and P. That will be taken at the end of the class. So go through it. The first problem, 8.1. The first problem. Find the area of the region bounded by the curve y square equals to x and the lines x equals to 1 and x equals to 4 and the x-axis in the first quadrant. So y square equals to x, that means a parabola, and the lines x equals to 1 and x equals to 4. So this region, isn't it? Isn't it? To the given curve, that is y square equals to x, that means y equals to here just write root over x, because this is on the first quadrant only. Okay, so what will be the area, required area? That will be integration 1 to 4 y dx. So just write y in terms of x, that means y equals to fx, the formula, from the formula. So 1 to 4 root x dx, isn't it? You do the calculation and tell me the answer. So 2 by 3 x to the power 3 by 2, the third bracket, limit 1 to 4, 2 by 3 x to the power 4 to the power 3 by 2 minus 1 to the power 3 by 2. That means 2 by 3, 4 to the power 3 by 2, that means 2 square to the power 3 by 2, that means 2 cube, 8 minus 1, 8 minus 1, that is 7, 7 into 2, 14, 14 by 3 square unit, area, so square unit, isn't it? Just do it in your copy and respond me with your answer. I got the response of Payal. Rest of the students, 14 by 3. Is it clear, the method? Okay, question number 2 and 3 is left for you. Try to do it at your home. Similar type of problem. Okay, 2 and 3, similar type of problem, that is left for you. We will move on to question number 4. Question number 4. Go through it. Find the area of the region bounded by the ellipse. Ellipse is given here. Okay, x square by 16. So given curve, the ellipse, x square by 16 plus y square by 9 equals to 1. Okay, find the area of the region bounded by the ellipse. That means the whole region. You have to find the whole region. You know this is the major axis and this is the minor axis. So this point will be, tell me the coordinate. Tell me the coordinates. This will be 4 0 and this will be minus 4 0. This is 0 3 and this is 0 minus 3. Now what will be the, first of all I am changing the whole y equals to in terms of x. Okay, first of all change it. Here y square equals to 9 into 1 minus x square by 16, isn't it? So y square equals to 9 by 16 into 16 minus x square. Okay, so y equals to, you may write plus minus, but whenever doing in the first quadrant, we will only take the plus value. 3 by 4 root over 16 minus x square. Isn't it? Respond me. Do the calculation in your copy and respond me. Okay. Therefore, the required area is a symmetric figure. These all are symmetric. So 4 into the area between the first quadrant. So 4 into limit 0 to 4 y dx. Isn't it? Respond me. Okay. So 4 into 3 by 4, I will take only the positive value, 0 to 4 root over 16 minus x square dx, or you may write here 4 square minus x square dx. I am erasing the upper portion. So here 4 will be cancelled out. That means 3. Now the formula of integration root over 4 square minus x square. There is a formula, or you may do it taking x equals to 2 sin theta. Okay, I am writing the formula here. You may do it taking x equals to 2 sin theta. X by 2 into root over 4 square minus x square plus 4 square by 2 sin inverse x by 4, when the limits 0 to 4. Okay. Now put the limits here, or I am telling you again, once again, you may do it taking x equals to 2 sin theta. Now put the limits. First of all, here putting 4, it will give you 0. Then 4 square by 2 sin inverse 1. 4 by 4, 1. And from the second portion, it will give you 0, and sin inverse 0 give you 0. So only 0. So that means it will be 3 into 8 sine inverse 1 means pi by 2. That means it will give you 12 pi square unit. Is it all right? Is it all right? Student, respond me. Do it in your copy and respond me. Do it in your copy and respond me. Is it clear? Is it done? Question number 5 is similar type of problem that is left for you. We will now move on to question number 6. Is it done? Welcome, Urpita. Can I move on to question number 6? I am erasing this one. Question number 5 is similar type of problem, so I am moving on to question number 6. Okay. Thank you. Find the area of the region in the first quadrant enclosed by x-axis. The line is given x equals to root 3y, and the circle x square plus y square equals to 4. Okay. That means x square plus y square equals to 2 square. Radius of circle is 2. Okay. And the line that will must passing through the origin. The line is given by x equals to root 3y. The line x equals to root 3y. First of all, this point is 2, 0, and we have to find the point of intersection. This point. I am drawing a perpendicular from this point on the x-axis. Okay. You have to find this region only. I am drawing one perpendicular here. So, given curve is x square plus y square equals to 4. And the given line that is x equals to root 3y. Okay. Now, from 1 and 2 solve this. From 1 and 2 we get, put it instead of x in the first equation. So, 3y square plus y square equals to 4. That means 4y square equals to 4, y square equals to 1, y equals to plus minus 1. That means, which implies x equals to plus minus root 3. This point, coordinate of this point, tell me, it lies on the first quadrant. So, coordinate of this point will be, tell me, that will be root 3 comma 1, and this point is minus root 3 comma minus 1. Therefore, point of intersection root 3 plus 1 and minus root 3 minus 1. But here we are interested with only this point, isn't it? Respond me, who are doing the class, please respond me. Respond me. Can you hear me? Please respond me. Otherwise, there is many times there are some technical problems occurred, so I can't understand you are listening or not. Okay. Coordinate of origin also 0, 0. And this point I am drawing on perpendicular from this point. So this point will be root 3 comma 0, because this lies on the base of the perpendicular lies on the x axis. So this will be root 3 comma 0. That means from the figure it is clear the first portion will be 0 to root 3. This will be along the line, and then root 3 to 2 along the circle. Okay. So the required region I am telling, important question, required region, that will be 0 to root 3 y bracket a within the bracket along line dx plus integration root 3 to 2 y along circle. That means here 0 to root 3, here y equals to x by root 3 dx plus root 3 to 2, this will be root over 4 minus x square dx. Isn't it? Isn't it? Tell me. Do the calculation. The first portion 1 by root 3 will be coming out from integration, and then x dx means 1 by 2 x square limit 0 to root 3, and this one, okay, this one 4 minus x square, that will be, just do one correction, root over 2 square minus x square, just do one correction here, root over 2 square minus x square. Isn't it? Isn't it? Okay. So first portion done. Second portion, the formula we have used in the previous problem, x by 2 root over 2 square minus x square plus 2 square by 2 sin inverse x by 2 limit root 3 to 2. Is it all right? Now from the first portion we got here, I am erasing again the upper portion, also the figure. One by 2 root 3, that is root 3 square, that is 3 minus 0, isn't it? And the second portion, from the second portion putting 2, it will give you 0, the first portion, and then here it is 2 sin inverse 1, then minus putting root 3, here it will be root 3 by 2, then root over 4 minus 3 minus 2 sin inverse root 3 by 2. Okay, this will give you root 3 by 2. Then here it is sin inverse 1, that is pi by 2, 2 into pi by 2, so pi minus root 3 by 2 minus 2 into sine inverse root 3 by 2. So it will be sine inverse root 3 by 2. It will be pi by 3. So root 3 by 2 will be cancelled out. So pi minus 2 pi by 3. That means ultimately pi by 3 square unit. You just do it the calculation in your copy and tell me. Respond me with your answer. You just do the calculation and respond me with your answer. Can you hear me? Hello, can you hear me? You do the calculation and respond me with your answer. Move on to question number 11. Question number 11. Rest of the problems are given as homework. Try to do it at your home. Any problem, then tell me in the next class. Okay? Question number 11. The figure is very important regarding this chapter. Figure is very important one. If you have drawn it incorrectly, then the problem also give you the incorrect answer. Find the area of the region bounded by the curve y square equals to 4x and the line x equals to 3. Y square equals to 4x, the parabola, and the line x equals to 3. Okay. You just do it, very easy one. You do it and tell me the answer. First of all, point of intersections. Point of intersections. X equals to 3. That means here this point will be 3, 0. Point of intersection y will give you different values, but it is not required to find the value of y. You only required the value of the x here, abscissa. That means here it will be 3, 0. So 0 to 3 required area. Also twice, because the whole area, so twice into 0 to 3 y dx. So twice 0 to 3 y means here 2 root x dx, only the positive one. So 4 into 2 by 3 x to the power 3 by 2, 0 to 3. That means 8 by 3 into 3 to the power 3 by 2. Isn't it? That means 8 by 3 into 3 root 3. 3 is cancelled out. 8 root 3 square unit. Is it clear? Question number 11. Is it clear? Here point of intersection is not required. That's why I am not finding this one. Is it clear? Okay, I am giving one hint of one problem, that is question number 9. Find the area of the region bounded by the parabola y equals to x square and y equals to mod x, the line y equals to mod x. I am giving hint here for question number 9. The parabola this region and this region. So you may calculate one region and then twice it, you will get the required region. This is the y square equals to, x square equals to y, or you may write y equals to x square, and this is y equals to x and y equals to minus x. Okay. What will be the required area? Tell me. First of all, find this point. This will be 1, 1. Draw one perpendicular from here. So required area twice, then this point will be 1, 0. This is 0, 0. So first of all, 0 to 1 along the line, that means x dx, minus 0 to 1 along the curve, so root x dx. Isn't it? Isn't it? Tell me. Okay, this one, this one y equals to x square, the curve. This will be x square dx. I am writing the equation of the curve here. Y equals to x square. So 0 to 1 x dx minus 0 to 1 x square dx. Okay. Just make one correction here. The curve is not root x. Y equals to x square. Y equals to x square. I think you can do the calculation yourself. Can you do it? The calculation? Can you do it, the calculation? Okay. So that's all for today. Before leaving the class, you just write your name for taking the attendance. Okay. So thank you all of you. Next day we'll be back again here and we'll solve the next problems and also discuss differential equation. Till then, goodbye and have a nice day.